Hello, gentlemen. Welcome to our video on chapter 7, section 1. So that's 1, or you could think 7.1. Our section is called Heat Transfer. What is heat? Now, we've got a couple different definitions of heat, but one simple one is this. Heat is a form of energy that results from the motion of atoms and molecules. Now, heat is important because it does something called transfer. That's what we're really invested on with heat. So heat transfer concerns the exchange of thermal energy or heat between matter. This is what we looked at in our investigation. In your investigation, you were trying to minimize your heat transfer from inside of that cup of water to the surrounding environment. So you built insulating layers around it, a thermos. Now, heat can be transferred in three, major ways. We'll just talk about three. There are others, but these are the three big ones. The first one is conduction. Conduction is the movement of thermal energy through matter by the transfer of vibrational energy. So kinetic energy between atoms and molecules that are in contact with each other. The key is contact. So when molecules are in contact, they transfer their thermal energy through conduction. An example of this would be cooking in a pan. So if you're cooking at home, your food is touching the pan. Heat from the oven goes to the pan. Heat from the pan cooks the food. They're all in contact with each other. That is conduction. Now here in red is a key point. When an object is at a different temperature from another body or another surrounding, heat flows so that the body and the surroundings reach the same temperature, at which point they are in thermal equilibrium. We talked about equilibrium when we talked about acids and bases. Equilibrium means, one side is not more energetic than the other side. It goes back and forth. Energy goes here, then it goes back. It goes here, then it goes back. They're in thermal equilibrium when the temperatures equilibrate. Another key point is that heat travels from higher temperature objects to lower temperature, from hot to cold. And we talked about that in class briefly already. Now, the second transfer method is called convection. Convection is the transfer of thermal energy by the physical motion of masses of fluid. Keyword, fluid. Now, a fluid in red here can be a liquid or a gas. So do not just simply think it's a liquid. A fluid can be defined as a liquid or a gas. And convection involves a movement of thermal energy through a fluid medium, like water or air, from one place to another. Example, hot water rises. Everyone knows that. So if I have like a pot of peas boiling, then the water at the bottom of the pot gets hot first, and it travels to the top of the water in that pot and goes through my peas. And water just keeps kind of circling around through those peas and eventually warms them up and transfers heat to them. Or hot air sweeping throughout. So throughout our city, we have hot, fronts, just sweeping through. That's due to convection. The last one, and very important, is radiation. Radiation is a transfer of thermal energy through space by means of electromagnetic radiation. Not particles, not through air or liquid or gas, but just through space. And it's through electromagnetic radiation, electromagnetic waves. Here, all bodies radiate heat when they are indeed hot. So anything that's hot radiates heat. We have electromagnetic waves coming from any object that's hot. An example will be the sun. The sun radiates heat. Another example would be a light bulb. It releases heat. If you put your hand next to a light bulb, you feel the heat being transferred to your hand. Even if it's a distance away, that's due to electromagnetic radiation. Also due to convection as well, I stated here. So we feel heat due in part to radiation and also in part of convection. The air particles between our hand and that light bulb are also being circulated into our hand to transfer heat, but we also feel the electromagnetic rays as well. So these are your 3 different methods of heat transfer. Know these and see if you can apply these concepts to your thermos. Take notes, gentlemen. Adios.